Hey folks, Mr. Dell here. We are going to explore percent decrease or increase problems. Given a word problem or a situation, determining or using percent increase or decrease. So, I'm taking these problems from CPM. Specifically, this is coming out of course two, and this is a parent guide, is what it is. These problems are from the parent guide. Percent decrease or increase is the name of the parent guide. And so I'm going to do numbers 1 and number 7 as examples while I'm explaining this concept. So let's look at number 1 first. It says 40 years ago, gasoline cost 30 cents per gallon on average. 10 years ago, gasoline averaged about $1.50 per gallon. What is the percent increase in the cost per gallon? Okay. So here's how we work these problems. First of all, I look and I say, okay, I've got a 30 cents is the initial. This is the original price that I'm dealing with for right now. Then I'm increasing in this case. I'm increasing, and I got to think about what that increase is. Increasing, and it's becoming now $1.50 per gallon, right? So I went from 30 cents to gallon to $1.50 per gallon. So it's increasing. The question is, what is that increase? So that's what I got to determine first. What is the money amount, the increase in dollars? If we look at that increase from 30 cents to 150, it increased $1.20, right? So my increase, or I could look at the subtraction to figure that out. 150 minus 30 cents. $1.50 minus 30 cents is $1.20. That's the increase, but it wants to know what the percent increase is. So I could say the increase is $1.20, but what is that percent increase? Well, most percent increase decrease problems can be generalized by finding what you want to do is first find. So, what percent, you need to find the percent. So, what percent of the original is the increase? That's what we've got to figure out. What percent of the original is the increase? And sometimes it's not increase, sometimes it's decrease. It's the same situation. As long as you know what that increase or decrease is and you know what the original was, then you can use this generalization to solve for that percent. And here's how that works. So I know the original and I know the increase. So I'm going to use this generalization to create an equation. So first of all, I'll write the statement. What percent of, in my case, it's going to be 30 cents here. What percent of 30 cents is, and then the increase in this case is $1.20. So this is the statement that I have to solve. And when I'm given this statement, it's a matter of writing an equation because I can see certain key words and the numbers that'll help me to determine an algebraic equation that I can solve. So first of all, there's what percent. Well, anytime it's a what, an unknown, we call that an x. Of means multiplication, right? And of what? Of 30 cents, and I'll put parentheses to show I'm multiplying x times 30 cents is would be equals $1.20. So here's my equation. And if I want to rewrite that to have that be a coefficient of x, 0.30x is equal to 1.2. So there, or zero point 0.3 even. I don't even need the zero there, 0.3. You can eliminate the zero. 0.3x is equal to 1.2. So now it's just a matter of figuring out what x is. So solving this equation, solve for x, we divide by the coefficient, 0.3. Why? Because that becomes a 1, right? And this gives our x alone. So x is equal to 1.2 divided by 0.3 is equal to 4. Now, x is 4. But if I go back and I remember x was my percent, the tricky thing with percents, though, is when you're dealing with percent in terms of as a multiplier, you never just have it as the raw percent. You have to change it into a decimal. So this x is the decimal of the percent. So how do you go from a decimal to the percent? You always multiply by 100. That's how you make something into a percent. So as a percent, this would be 400%. Because we could see it basically the percent increase, it increased 4 times the amount, which would be a 400% increase. 4 times the amount is a 400% increase. So there's my answer for that question. Okay. All right, let's move into another one so we can see just one more. We're going to do number 7 here. So I'm going to move that. So number 7 on this page. Okay. It says that in 1984, there were 120. So I'll make my notes. Year 1984, there were 125 students for each computer, right? 125 students for each computer. By year 1998, there were 6.1 students for each computer. So this right here is a decrease. We went from 125 to 6.1. So it says, what is the percent decrease in the ratio of students to computers? So how much did that decrease? First of all, my decrease, I can figure that number as far as number of students. If I take 125 and I subtract 6.1, you would get 118.9. So it decreased 118.9. That's the decrease as far as like the number of students per computer. But I want to know, what is this as a percent? That's what I need to know. So remember, we go back to this generalization, right? So this right here is a generalization for every percent decrease increase problem. As long as you know the original and you can determine what the increase or decrease is, you can find its percent. What percent of the original is the increase? So in this case, what percent? So what percent? X percent. What percent of 125 is 6.1? That's what I need to figure out. So my equation I'm going to write is 125x equals 6.1. So we divide both sides by 125. We figure out what our x is. So I've got x is equal to, if I take this one, I'm going to use a calculator for. Clear. So let's see, what do I have? I'm going to have 6.1 divided by 125. And looks like I get 0.0488. I'm going to write them all out because there's just 4 digits there. So if I'm looking at what that percent is, remember that's the decimal, that's the multiplier. Whenever you're using percent and multiplying by a percent, you always first put it in decimal. So to make it into a percent, to convert it to a percent, you've got to multiply by 100. What does that do? That makes the decimal place move twice. When you multiply by 100, you're moving that decimal place twice. So my percentage would be 4.88%. And in this case, remember what we did was a decrease. So it's a decrease. Oh, I did. That's wrong. I just realized. Back it up. Let's catch my mistake. This is good. Catch my mistake. My mistake is right here. Because I was actually looking for what the percent of the original to the new, and I caught myself because I realized that's a very small percent decrease, and I'm decreasing quite a bit, and only about 5% is not very big. So that's what caught my eye as I'm trucking along and realized, nope, this isn't right. So I did that wrong. So let's change this real fast instead of redoing the video. So it's not supposed to be X percent of 125 is 6.1. It's X percent of 125 is 118.9, right? Because that's the actual decrease. This was the new. So I apologize. Let's rewrite the equation. So it's 125x is equal to 118.9. That makes more sense. And when I solve for x, Let's see what we get. I've got 118.9 divided by 125. I get X there. That makes more sense. X is equal to 0.9512. And again, I want to make this into a percent. So I multiply by 100. That's how I make something into a percent, which moves the decimal place twice. So it's 95.12% decrease. There we go. That makes more sense because that's a pretty significant drop, right? And so it's going to be a very large percentage as far as that's concerned. All right, there we go.